We're talking about solving absolute value inequalities. In this case, we have a word problem. The ideal weight of one type of model airplane engine is 33.86 ounces. The acceptable margin of error or tolerance for the weight of the engine is 0.05 ounces. Write an absolute value inequality that models the relationship. Find the range of acceptable weights for this engine. So basically, we want to find an equation or inequality that would allow for any engine that would be 0.05 greater or 0.05 less than the ideal weight for the engine. So we can't really compare, and the only thing that we can compare is the weights of the engine. Set the engine on a weight, on a scale, and see the weight. So once we have it set, really the only thing that we can check for is we can check the actual weight. Because if we're in, and then we can only compare it to the target weight. Okay, so let's say it was on a balance or something. We have one engine on one side, and we have the target weight on the other side. Well, if we add two engines that are very close to 33 together, we're going to end up somewhere be 60, 67, somewhere in there. So that's not, that number is not going to help us be very accurate for an answer. But what we could do is we could subtract these two. Take this engine and subtract this engine, and then we're going to get some value. It's going to be very small because hopefully these are very close together. Well, if this is above the target weight, it'll be positive. If this is below the target weight, it'll be negative. So one way that we can get rid of that is we can say absolute value. Now, no matter what this is, if this is smaller than the target, it would be negative, but the absolute value changes it back to be positive. So the tolerance has to be, it cannot be greater than 0.05. It has to be less than or equal to. So in this case, when we substitute our values in, we don't know what the actual weight of each engine will be, but we'll have some weight W. We know that the target weight is 33.86, and we know that it is going to have to, whatever the difference between the weight of the actual engine and the target weight has to be less than or equal to 0.05. And remember that we have less than So we should be thinking about and when we write these inequalities. So in order to solve this, we have to get rid of the absolute value. So we have one where we consider the positive. And we just write down the inequality without the absolute value sign. And just write it down exactly as it is. And then we have once where we consider the negative. So we write it down as 33.86. We change the answer to negative. And because we change that to negative, we have to change the direction of the inequality. And now we can solve. Over here, we add 33.86. And then we get W is greater than or equal to 33.81. And here we add 33.86. And then we get W is less than or equal to 33.91. So last thing, we can write down the solutions for this. W is less than or equal to 33.91, and W is greater than or equal to 33.81. Whenever we write these final answers, we want to have the smaller one on the left. So we have 33.81 is definitely smaller than 33.91. So we'll write that one on the left. Okay, we keep the sign the same. So the pointy side of the arrow points to the 33.81. So we want to make sure that stays the same. Our variable in this case is W. And same thing, we want our arrows pointing towards W. So we want to keep that the same. And then we have 33.91. We can also write this in interval notation. And basically, we're just going to write down our two boundaries here, 33.81 and 33.91. And because these are both equal sign, these are both included. So the engine, any acceptable engine can be between 33.81 and 33.91 ounces.